The last step in subnetting a network ID is working out the IP address ranges, because after all, that's what we actually assign to the systems. So here I rewrote the first three network IDs, 172.20.00, 32.0, and 64.0, and we're all using a prefix of /19, of course, and I'd like to work out the first and the last IP addresses for the first two network IDs. Now, I'll show you the long way to do this in a minute, but before I do that, let me just show you the shortcut, because this is what you'd probably want to use. The first number we're looking at here is the actual network ID. If you recall the definition for a network ID, it's the one where the host bits are all zeros. So 00 has the host bits as all zeros, 32.0 has the host bits as all zeros. If we were to think of this like a number line, and this was the first network ID, that was the second, this is the third, and the line continues down, we have 8 of them. Right after the network ID, the first IP address you have is the first valid IP. In this case, that would be 172.20.0.1 would sequentially be the first IP. This is the first valid IP. And of course, 0.2 is the next one, 0.3. What's the last one? Well, this IP started off right here. It's right after the network ID. The next network ID is 172.20.32.0. What is the IP that's right before that one? Well, that is 172.20.31.255. This IP is actually the one where the host bits are all ones. This is my directed broadcast IP address. My last valid IP is therefore the one right before this one. That's 172.20.31.254. Let's try this again. The next network ID is 172.20.32.0. That's my network ID. The IP that is sequentially right after that is 172.20.32.1. The IP that is right before the next network ID, 64.0, is my directed broadcast IP. It is 172.20.63.255. The last valid IP, therefore, is 172.20.63.254. So to work out the range of values for each network, I'm just using the next network ID as my boundary. For the 20.0 network, the first IP is 20.0.1. The next network ID is 20.32.0, so the last IP, the directed broadcast IP, is 31.255. The last valid IP, therefore, is the one right before the directed broadcast IP, 31.254. For the 2032 network, the first IP is 32.1. The next network ID is 64.0. Therefore, the directed broadcast IP is 63.255, and the last valid IP address is 63.254. The long way of writing all of this out is to look at the binary. So let's look at 172.20, and we'll look at the host bits in binary. This is 172.20.0.0/19. Our subnet bits are therefore these three right here, and the last 13 bits are host ID bits. The first IP address in this range will have the host ID bits as mostly zeros, and this last bit would be a 1. In other words, the first IP address in this range would be 172.20. The subnet bits would be 000 because this is the 172.20 network, and the host bits would be 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8. This entire thing you're looking at is 172.20.0.1. The directed broadcast IP would be 172.20. The subnet bits would be 000, and the host bits would be all ones. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. What is this? Well, this is 172.20.31.255. This IP is the directed broadcast IP. The last valid IP is therefore the one sequentially right before this. That's the 172.20. The subnet bits are 000, and the host bits are mostly ones, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, but the last bit is a 0. This is the combination sequentially right before the directed broadcast. And that IP that we're looking at here is 172.20.31.254. So this is the long way of looking at it, and the shortcut is simply to take the network IDs as they are, think of them as a number line, and just tell yourself this. Right after the network ID sequentially is the first valid IP. Right before the next network ID is the directed broadcast IP, and right before that is the last valid IP. And you can use that trick to easily work out the range of IP addresses for each network ID.